Hello, everybody. This is Bert Dixon here to give you a quick lesson on complex fractions and equations in quadratic form. This corresponds to section 3.1.2 in your CPM pre-calculus textbook. So complex fractions are whenever we have fractions inside a fraction. For example, here in problem 1, we have fractions, two fractions in the numerator, two fractions in the denominator. So anytime we have a fraction within our fraction, that's considered a complex fraction. So the basic strategy for simplifying complex fractions is to just multiply the numerator and denominator by the common denominator of all the denominators that you see. So for example, in problem 1, the denominators I see are 7, 3, 7, and 3. So what's the common denominator for the numbers 7 and 3? That would be 21. So if I multiply the top by 21 and the bottom by 21, this is what happens. I have 21 times 10 over 7 minus 21 times x plus 3 over 3 divided by 4 times 21, or 21 times 4 to be consistent, over 7 minus 21 times x plus 3 over 3. Now, this step you may be able to do in your head in the future, but I'm just showing step by step what we're doing. We're multiplying here, 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 and here. Okay, and so now these can all be simplified. 21 divided by 7 is 3, times 10 is 30. 21 over 3 is 7. 7 times x and 7 times 3, that gives us negative 7x minus 21. Here I have 21 divided by 7, which is 3, times 4 is 12. 21 over 3 is 7, so we get minus 7x minus 21. So what I end up with altogether is negative 7x plus 9 over negative 7x minus 9. And that is the final answer. Don't make the mistake of thinking that you can cancel these. Those are not common factors that we can cancel. You cannot cancel things that are being added and subtracted. You can only cancel common factors that are being multiplied. So these are not common factors, they're common terms, but terms cannot be canceled, only factors can. So that is fully simplified. Okay, now let's take a look at problem 2. In problem number 2, I'm going to put a denominator under the k squared so we can see our four denominators. We have 7, 4, 7, and 1. So the common denominator of all four of those numbers is 28. And so I'm going to multiply the top and the bottom by 28. 28 here and 28 here. So when I multiply here, again, this step, you might be able to do some of this in your head, but I'm going to go ahead and show the steps here. So this would be 28 times 2/7 plus 28 times k plus 4 over 4 divided by 28k squared over 1 plus 28 times 12 over 7. When I simplify this fraction, I first do 7 into 28, which goes in 4 times. 4 times 2 is 8. And then 28 divided by 4 is 7. 7 times k and 7 times 4 gives me 7k plus 28. And then in the bottom we have, this is just 28k squared. And then here, 28 divided by 7 is 4, times 12 is 48. So simplifying the top, I have 7k plus 36 divided by 28k squared plus 48. And that is as much as I can simplify. All right, let's skip down to, let's see. Let's skip down to this one, number 7. This one has variable expressions for all the denominators. So looking at the numerator, I have the denominators of x minus 3 and x. And down here, I have x plus 3 and x. So I have a common denominator considering all those factors. My common denominator is going to be x plus 3, x minus 3, and x. Same thing down here, x plus 3, x minus 3, and x. So no matter what the denominators are, we look at all the denominators in our complex fraction, we find the common denominator. Okay, so here, when I multiply all of this times the first term, I have 2x plus 3, x minus 3, x over x minus 3. Then when I multiply here, I have minus 7 times x plus 3, x minus 3, x over x divided by, when I multiply all of this here, I now have 2x, x plus 3, x minus 3, x divided by x plus 3. And then I have 5, when I multiply here, I have 5, x plus 3, x minus 3, x over x. Okay, simplifying, in this expression, I have an x minus 3 and an x minus 3 in the top and the bottom. Those are common factors, and they can be canceled. So what I'm left with is 2x plus 3, x. In this expression, the x's cancel. I have now minus 7, x plus 3, x minus 3. In the denominator, the x plus 3's cancel. I have 2x, x minus 3, and x. And then here these x's cancel. I'm left with 5, x plus 3, x minus 3. Now you could leave your answer like that, or if you wanted to expand this out, you could expand that out and expand all this out and have a quadratic expression in the top, and in the bottom actually it would be a cubic expression in the denominator. But you can do that, or you can leave your answer like that. Okay, so now I'd like you to try a couple. Let's start with number 4 and number 8. So if you want to pause your video, go ahead and try problems 4 and 8, and then press play when you're ready to check your solutions. For problem number 4, our common denominator, our two denominators are 7p and p, so our common denominator would be 7p. So I'm going to multiply the top by 7p and the bottom by 7p. So in the top, that gives me 77p. And in the bottom, I have, when I multiply here, I have 7p times 5 over 7p. And then here I have 7p times 5 over p. And so on top, again, we just have 77p. In the denominator, these 7's cancel, these p's cancel, I just have 5. And then these p's cancel, I have plus 35. And so what I end up with as my final answer is 77p over 40. For problem number 8, our common denominator would be x squared, x plus 5. And that gives us, when we multiply here, 2x times x squared times x plus 5 over x plus 5 minus, when I multiply here, 7x squared x plus 5 over x squared divided by, here I get 6x squared x plus 5 divided by x plus, when I multiply here, 5x squared x plus 5 over x plus 5. Okay, so if we cancel common factors, here the x plus 5's cancel, here the x squareds cancel, here this x cancels with one of these x's, so I'm going to cancel those, and then here the x plus 5's cancel. So what we're left with then in the top is 2x cubed, that's from this. Here we have this, minus 7x minus 35. And then in the denominator here we have 6x times x plus 5, so that would be 6x squared plus 30x. And then here we have plus 5x squared. And so that simplifies uh, 11x squared plus 30x. All right, the next topic we're going to talk about is equations in quadratic form. So a quadratic equation is normally something of the form ax squared plus bx plus c equals 0. And so there are other equations that are not necessarily quadratic equations, but can be rewritten by using a u substitution to put the equation in quadratic form. For example, with problem number 1, this is not a quadratic equation because it has a 4th degree in it. But if we do a simple substitution, if we say u is equal to x squared, look at what happens. This is really x squared squared, so that is u squared. This is u, so that's 10u, and then plus 21 equals 0. Now we have a quadratic equation. We have a 2nd degree equation. Okay, so equations are in quadratic form anytime this expression squared is the same as that expression. So that's how you tell when an equation is in quadratic form. If this expression, it has to have 2 or 3 terms. If the variable part of the 2nd term squared gives you the variable part of the 1st term, then it is in quadratic form. Okay, and so now that I have this one written in quadratic form here, I can factor this. This would be u plus 3 times u plus 7 equals 0. And then, so that would give us the solutions u equals -3 or u equals -7. So now that we know that u is equal to x squared, we would say x squared equals -3 or x squared equals -7. And both of these have no real solutions because you can't square a number and get a negative answer. But if we include complex solutions, this would have solutions of x equals plus and minus 3i, and this one x equals plus and minus 7i. So if we're trying to solve equations in real solutions, we would say no real solution. If it says solve the equation over complex numbers, then we would have 2 imaginary solutions. Okay, number 2. This is also, we can tell this is also in quadratic form because this expression squared gives you x to the 6th. And so if I choose this to be u equals x cubed, look at what happens. This is just u squared, because x to the third squared would give you x to the sixth. So that's u squared minus 2u plus 1 equals 0. That is u minus 1, u minus 1. And so that gives us the solutions u equals 1, which means x cubed equals 1, which means x equals 1. Okay, go ahead and pause your video. I'd like you to try number 3 and number 4, and then press play when you're ready to check your solutions. Number 3 is in quadratic form because x squared squared gives you x to the fourth. So this is what we want to choose as u equals x squared. So then we get u squared minus 5u plus 4 equals 0. That will factor as u minus 1, u minus 4. And so that gives us u equals 1 or u equals 4. So x squared equals 1 or x squared equals 4. And then the solutions of this are x equals plus and minus 1. And the solutions of this are x equals plus and minus 2. For problem number 3, this one looks a little different than the other ones, but realize it does still fit the same form. This squared equals this. So it's always the middle one that we want to choose as u. U is equal to x to the 1/2, which is the same as root x. Same thing. And so this would be 3u squared plus u minus 4 equals 0. So then we try to factor 3u, 2, u, and 2. Let's see, that's going to give you, is that going to factor correctly? That would give you 3u squared, 6u, and 2u. No, that's not going to work, so we'll have to change the numbers at the end. This one might be 4 and 1. So that would be 3u squared, 3u, and 4u. That will work if I make that one positive and that one negative. So I have it factored correctly now. So this gives me 3u plus 4 equals 0, which means u is equal to negative 4/3. This one gives me u equals 1. And so now substituting those back into this, that would tell me that root x equals negative 4/3, which is impossible, so there's no solution for that one. This one gives me root x equals 1, which means x equals 1. And that's it for today's lesson. Have a great day.